In this problem, I'm given a circuit and a list of variables to find. Unlike some of our practice problems, in this problem, I'm not asked to find the variables in the order which necessarily is the best way to approach the problem. So I have to look at the problem and figure out where do I want to start this puzzle. When I look at this problem, I think that the easiest thing to do is to look at this as an overall series circuit. And to do that, I'm going to think of resistors 1 and 2 as one resistor I'm going to call R12. And then I have that in series with resistor 3. If I also look at this problem, I see that I already have my resistance at 3 and my current at resistor 3. So the first thing to do, because it's pretty obvious there, is to solve for my voltage. I have Ohm's law, so I can say V3 equals I3 R3. My voltage at resistor 3 is equal to 1 times 4. My voltage at resistor 3 equals 4 volts. And I'm going to go ahead and add this to my list of givens. And then I'm going to say, what is the best thing to find next? Well, if I'm looking at this as an overall series circuit, I could start by combining some of the things in R1 and R2 so that I have that one resistor R12. So I'm going to say I want to find my resistance of R12. And since R1 and R2 are in parallel, I'm going to say that my total resistance there equal to 1 over R12 equals 1 over R1 plus 1 over R2. So 1 over R sub 1, 2 equals 1 over 2 plus 1 over 3. I need to find a common denominator for my fractions. In this case, that's 6. So I can say 3/6 plus 2/6. And then I have 1 over R12 equals 5 over 6. To get R12 on top of that fraction, I need to do the inverse of each side. So then I end up with R12 equals 6 over 5, or 1.2 ohms. So now I can think about this being a series circuit again, and I can say, well, in a series circuit, the total resistance would be equal to R12 plus R3. So my total resistance would equal 1.2 ohms plus 4 ohms. So my total resistance would equal 5.2 ohms. I can go put that in my list of givens up here. Now I'm going to move on and find my total voltage. So to find my total voltage, I have total voltage equals I total times R total. But if I look up at my list of givens and my list of knowns or things I did figure out, I realized I didn't find my total current yet. So remember, we keep saying that we're kind of looking at this as a series circuit overall. So I'm going to go back to those series rules. And in my series rules, I know that my total current is equal at all resistors in a series circuit. So my total current would be equal to current at resistor 1, 2, and current at resistor 3. So I can say that I total equals I1, 2, which equals I3, which was given to me, and that's 1 amp. So now I can go back down here and find my total voltage. So I can say that my voltage total equals the 1 amp times my 5.2 ohms of resistance. My total voltage equals 5.2 volts. I'm going to add both of those things to my list of givens up here. So my total current we found was 1 amp. My total voltage found as 5.2 volts. Now, thinking about this as a series circuit, I can say, according to my series rules, my total voltage is equal to the voltage in resistor 1, 2, plus the voltage in resistor 3. So now if I want to find the voltage in resistor 1, 2, I can subtract the voltage 3 on both sides. So I get that my total voltage minus the voltage in 3 equals the voltage in 1, 2. So I can say 5.2 volts minus the 4 volts, which gives me 1.2 volts. That's my voltage in 1 and 2, or 1, 2 combined, I'm sorry. And then according to my parallel rules, because R1 and R2 are in parallel to one another, I can say that the voltage of resistor 1, 2 is equal to the voltage of resistor 1, which is equal to the voltage of resistor 2. So now I can say that this 1.2 volts we found is equal to voltage 1, which is equal to voltage 2. So I can come back and add that to my list of found information. And the last things I have left to find is the current at resistor 1 and the current at resistor 2. And once we have our resistance and our voltage, we can go right back to Ohm's law and solve for those. So I have V1 equals I1 R1. And I could say that V1 over R sub 1 equals I sub 1. So 1.2 divided by 2 equals my current at resistor 1. So that's 0.6 amps equals my current at resistor 1. And then to find my current at resistor 2, I'm going to do exactly the same thing. So V2 equals I2 R2. So V2 over R2 equals I2. So 1.2 volts over 3 ohms equals the current at resistor 2. And that gives me 0.4 amps. So if I want, I can come back up and add that to my list as well. So 0.6 amps is the current in resistor 1, and 0.4 amps is the current in resistor 2. If I want to check my work here, I can look back at the series rules, and I can say that I total, it's going to change colors here, equals I12 equals I3 so I total equals, since resistor 1 and resistor 2 are in parallel, I12 is equal to I1 plus I2, which equals I3. Remember, we did solve this a little bit earlier over here. So now I total, which was 1 amp, equals 0.6 plus 0.4, which equals I3, which was given, which is 1 amp. So I have 1 amp equals 1 amp, which equals 1 amp. And that's just a good way to check our work at the end.